That means we gotta find all the asymptotes and intercepts. And how will we do that?
At the factor first.
Yep, we gotta factor first. I need everybody participating. Jacob is my best volunteer ever, but I need everybody helping us out here. So let's see, how does the top factor, Brenda?
Would be x minus 4, I think.
Now be careful, they have to multiply to get
Oh,
you 5.
it's a 5. My bad. I thought it was an 8.
Oh, there's an 8 on the bottom, but the top number's a 5, yeah.
Minus 4 plus 5. I mean plus.
Minus 5 plus 1. Yeah. Because 5 times 1 is 5, right?
Mm.
Okay, the bottom. Now be careful on the bottom because there's a 2 in there and we'll need to take that out, right? Now, what happens when I take the 2 or the GCF out of the denominator? What do I have left there?
X minus 2, x plus 2.
Yep, we gotta recognize that's the difference of squares, x minus 2, x plus 2. Okay? Well, guess what? I thought something was going to cancel, but nothing did. Right? So, in a blank that says, what are the holes? We're going to say there aren't any, right? No holes. What are there, though? What do we have?
Vertical asymptotes and horizontal asymptotes.
Where are the vertical asymptotes? The vertical asymptotes come from the bottom. So if that wasn't automatic for you, write it next door to it. Write down, vertical asymptotes come from the denominator. So I can see that I'm going to have vertical asymptotes at 2 and at negative 2. Because that's what would make the denominator 0. Now, it might be easier to look at the original problem. Where is the horizontal asymptote in the original problem? Might be easier to look there. Box in your x's. The horizontal asymptote is y equals 1/2. Ella, do you see that?
Yeah.
1x squared over 2x squared. All right, how do I get my intercepts now? Write it down. Your intercepts are 2 points, right? And you have a 0 in the x spot and a 0 in the y spot. Doesn't matter which one you do first. You do them separately. So
5, 8.
here we go. If we put 0 in for x, and you can do it here, or you can do it up here. I like to do it up here because there isn't as much, first of all. And I know that if I put in zeros, all of this disappears. If those are all zeros, they're like gone. And all I have left is 5/8. But if you put them in here, you're going to get the same thing. You're going to get negative 5 times 1 over 2 times negative 2 times 2. And when you do that arithmetic, I just put 0 in all those spots. I get negative 5 over negative 8, which gives me my 5/8.
Okay.
So we're not going to stew or be concerned about where we put it in. We put it in at the beginning, at the original, or we put it in our factors. Doesn't make a single bit of difference. That's my y-intercept. That's slightly higher than 1/2. 5/8 is a little bit bigger than 1/2, which is where my asymptote is. All right, now I need to let y be 0. So remember, in the original problem, here's my factored form right here. This is my factored form. What the thing equals y equals. So now I'm going to put a 0 in here. I like to think of that as 0/1, so I don't get freaked out. I'm just going to cross multiply. I'm going to cross multiply. So 0 times anything is 0, right? Equals 1 times this, which 1 times anything is just itself. So when I cross multiply, I have 0 equals 1 times all that, which is just all that. And then it's easy. What are the x-intercepts going to be? There's going to be 2 of them because you have 2 parentheses. Where are they?
+5 and -1.
Yep, +5 and -1. So 5, 0, and -1, 0. Now, I referred to those on some papers and notes and things as x-intercepts, but today, academic kids, we talked about those can also be called what? Zeros, yeah. So we're not going to be confused. X-intercepts and zeros are the same thing. Okay, so we have our horizontal asymptote, we have our vertical asymptotes, we have our intercepts, and we agreed there were no holes. All right, that's it, folks. Based on this, we have to draw a picture. Anybody have a thought on what this looks like?
Parabolas? Like, or I don't know if that's the correct term, but it's like positive parabola and then negative parabola. So it's like.
So, Jacob, are you thinking like this right here?
Yeah, yeah.
Okay, wait, that can't possibly be right because I have to connect that point. And if I drew in something up here and something down here, would I pass the vertical line test?
No, sorry.
You cannot ever have pieces on top of each other. So whatever you draw, don't put anything on top of each other. So like if you do something over here, you couldn't draw something down here. They never are stacked. You have one thing over here, one thing in the middle, and one thing over here.
This is 4.
Uh-huh.
Can we do one, like, that's kind of what we did, like, when we first started doing it, like an x minus something over an x minus something? Just a more simple one?
Well, I need to finish this one.
Okay.
Okay.
Sorry, after that one.
Yeah, okay? But you got this, Ella. You know exactly what this is going to look like, Ella, because these 2 points need to be connected. So I'm going to go ahead and connect them. They have kind of like a tangent shape. Now, some of you might be thinking, Mrs. Ford, one time you did this and there was a parabola in here. Well, this can't be a parabola because I don't have an intercept over here. So when I connect those two, I got to keep on going because there's no intercept on this side to bring it back down. Now, Ella, the basic problem, the most simple of all the problems, the kind you want to do has a piece here and a piece here, right?
Mm-hmm.
All right. So let's look over here for a second. I have a point on this side, right? There's a point. So can you kind of see a shape there?
Yeah.
That's exactly what you were talking about.
Okay.
And now I need something on this side too. What's going to be on this side?
Are you going to use the -1, 0?
No, I already used that. So now I'm talking about on the left side of this line. What do I draw over here? What shape am I going to draw over here? I have the middle covered, and I have the right side covered. Now I need to do the left side. Anybody have a guess?
would it be like would it be like the same shape on the right side, the far right side, but it's on top?
Exactly. That's it. Nope, that's exactly right, Jacob. That's where it's at. Now, I want to talk about this, Ella, because it goes back to what you were saying. The most basic, simplistic problems, this is what they look like. You've got something in this corner and something in the opposite corner. If you look at this picture, I have, this I've already got drawn. So the opposite corner from this would be up here. So that's why it's up there. And then here, I already have this drawn, and the opposite corner for this is down here. So that opposite thing still happens. It just happens in more sections than 2. Okay? Now, I'm going to give you a problem to work on while I ask the rest of these guys some questions about that picture. All right? You do not need to worry about what I'm talking about. So I don't know, can you turn me off so you don't hear me? I mean, I don't care, I just don't want to bother you. All right, so here's what I want you to sketch now. Just a regular old picture. Make sure you label everything, okay? So let's do x plus 5 over x minus 3. All right, so sketch that one. All right? Now, you other guys, I'm going to write some questions up here, and I want you to see if you can answer them, okay? So these are going to be limit questions. I'm kind of scattering them all over the place. All right, so I'll number them. So you're going to have 8 limit questions that kind of go all around here.
Lauren. So on the actual graph like itself, how did you know you had to do like the line on the left side?
Because you're always going to fill each section. You are not going to have any empty pieces of the graph. So when you put in these 2 vertical asymptotes, let me get everything else out of there. I have 2 vertical asymptotes and a horizontal asymptote. That's my picture. No axes or anything. There's going to be something over here, something here, and something here. Your vertical asymptotes divide your space up into sections, and every section must have something drawn in it.
So like in class, like even though they only had like 2 things on it, they were covering all the sections, so it worked?
Yeah, because you only had 1 vertical asymptote. So 1 vertical asymptote is going to shift you in to the right side and the left side. Your vertical asymptotes, if you only have 1, you got a right and a left, so you're going to have 2 pieces. If you have 2 vertical asymptotes, you have a right, a left, and a middle, so you're going to have 3 pieces.
Okay.
That makes
sense.
Yep.
Thank you.
Ella, are you done with your picture?
Yeah, I think so. I have a vertical circle asymptote at +3.
And you labeled it x equals 3.
Yeah.
Yep, all right.
And then I have what did you say it was called with like the half C that goes up?
Okay, wait, I need a horizontal asymptote. Did you put a horizontal asymptote in there?
Yeah. At -5.
No. Your horizontal asymptote, you box in the x's.
Oh.
Make a note
So
of
when
that.
I do it at 1, 1.
Y equals 1. It's 1 over 1.
Okay.
1 over 1,
I got it.
which is 1. All right, so make a note of that so you remember it next time.
Yeah.
Now, yes, you're going to draw in. You only have these 2 asymptotes. So like Ellie was asking, you're going to have something over here and something over here. But we need to plot our intercepts. So did you do this part? Did you find did you put the zeros in?
I just started I haven't finished that yet.
You haven't finished it yet? Okay, we'll keep going on that. The rest of you guys, do you have this figured out?
I messed up. I accidentally did all those questions for the previous problem, not this problem. So that was my bad.
Yep. We're doing this problem right here. So we're answering all these questions I have scattered all around for that. So who got an answer to number 1?
I put 0. Is that correct?
I don't know. Let's come over and look at our picture because that's what I got to do. It says I'm approaching -1. X is approaching -1. Isn't this where X is -1?
Mm-hmm.
And isn't that a point?
Yeah.
So your limit is always the Y value. And if you have a point, your Y value is just the Y value. So when you said 0, you were correct. That is the limit. Because as you approach -1, doesn't really matter which side, as you approach -1, your Y value goes to 0. Very good. Was that Brenda?
Mm-hmm.
Very good. All right, who got something for number 2?
I put +infinity.
All right, let's see if that's right. Now we're approaching 2, which is not a point, it is an asymptote. We're approaching 2 from the right side. This is the right side, right? Here's 2, this is the right side of 2. As I follow my curve, I don't think I'm going to positive infinity. What am I doing?
Negative?
Yeah, I'm going to negative infinity. That's going down, guys. Isn't it? So as you get closer to closer to 2 from the positive or the right side, you're going to negative infinity. So that one should be negative infinity. Because the curve is going down on this side. All right, anybody get an answer to that one? Number 3?
Positive infinity?
Nope. Where is x approaching negative infinity? Where am I looking on my picture?
So I'm looking at the wrong one.
All the way to the left, right? So I'm saying as I go all the way to the left, that's what this says, go all the way to the left, what is my curve doing? What are these y values doing? Aren't they coming down? But are they going down? No. What are they getting closer to?
-1/2? Or it's like, because y equals 1/2. So it's getting closer to 1/2.
Closer to 1/2 from the top. We're getting closer to 1/2 from the top. This curve is coming in toward 1/2 from the top. All right, so you guys, we've kind of missed a lot of those so far, so take another look at these. I'm going to come back over to Ella for a moment. Ella, have you figured out where your intercepts are yet?
Is it one of them at 8?
No. All right, let's stop and talk about this, Ella. I want you to write this down. Okay, did you write this down right here?
Yeah,
See
I
what
have
I'm
that written
pointing?
down.
Okay, so this is a point, and that's in the X spot. So you're gonna come up and you're gonna put 0 in for your X's. So if you put 0 in for your X's, what do you have on the top?
5.
Okay, and what do you have on the bottom?
-3.
So your intercept is -5/3. So your y-intercept is right there. I plot that point on my graph, -5/3. That's 1 2/3. If you want to think of it as a mixed number, if you're having a hard time figuring out where it goes.
Okay.
All right, so how did I get that? I did exactly what the point said. I let x be 0. I put in zeros.
When you put in the 0 for the y,
Okay.
would you put, are they just going to still be the x's are by themselves in there, so it's going to look like that?
So I'm
Okay.
going to let y be 0.
Yeah.
So now I'm going to cross multiply. So what do I get when I take 0 times something?
0.
Equals. What do I get when I take 1 times something?
Whatever that is, it's 5.
Exactly. So now when I solve that equation, x plus 5 equals 0, so what does x have to equal?
-5.
Yep. So you got a point at -5. So clear out here, right?
Yep.
Now you're ready to sketch, Ella. You got a point here and a point here. Does it make sense to you that they're going to be connected?
Yeah.
And then as soon as you put that one over here on the left, what's going to happen on the right? What are you going to draw over here?
You get the same kind of thing up there at the top.
Yep, right
in the
here.
first quadrant.
Yep, right up there. Okay, you got time for one more, Ella?
Yeah, I can do one more.
All right, and then I'm going to come back to you guys. You better have answers for all these, the rest of you. All right, so Ella, I want you to do this one. I want you to do exactly what we just did. I want everything labeled and a curve drawn, okay?
Okay.
All right, so do that one. All right, you guys, moment of truth. What'd you get for number 4?
Positive infinity.
All right, Jacob answered that one. Each one of you's got to answer one. So he said positive infinity. Let's check it and see. This says we're approaching -2 from the left. So here's -2. Here's the left. Follow my curve. As I get closer to -2, where's my pencil going? To positive infinity. You got it right. Good job. All right, somebody else tell me what you got for number 5.
1/2 and then the negative.
Oh, wait, I think I asked the same question twice. Let me change this to
Yeah,
positive.
you did. I think it was like 1/2 positive. That's what
Yeah,
we
but
got.
I don't want to do that one. Let's do this one. I just changed the problem, so that's unfair. But we're going toward positive infinity. Where's positive infinity?
On the right.
Yep. So as I follow my curve and go to the right, as far as I can go, just keep going, going, going. What is happening to the curve? What is it getting close to?
1/2.
Yep. And it's coming in on the bottom, right? It's getting closer to 1/2, but it's coming in on the bottom. Good. All right. This says, this is number 6, let x approach 5. Now, don't even worry about this, because what's 5? Isn't 5 a point? And what do we know about limits? Limits are y values. And if I have a point, don't I already have my y value? It doesn't make any difference which side I'm coming from. I'm going to head right to 2. Or I see right to 0. Right to 0. All right, what about this one? Number 7. Find the limit as x approaches 0 from the positive side. Now, what's at 0?
A point.
A point. What's the answer?
5/8.
Yes, indeed. This says x approaches 2 from the left. Now, 2 is not a point. 2 is an asymptote, right? So I'm coming at the asymptote from the left. What is my picture? Here's the asymptote. Here's the left side of it. What is my curve doing as I get closer and closer to the asymptote?
It's going up.
Yeah, to positive infinity, right? There's nothing stopping it. It's just going to keep going and going and going. All right?
Mrs. Ford,
Yeah.
I don't know if we had the time, but I was wondering if we could go over a homework question, if
Yep.
that was possible.
Yep, I'll do that right now. I'll do that right now. Which homework question are we going over?
I don't know how everyone else or like what others are thinking, but I was particularly confused on 2.6b.
Yeah, I was too.
Okay, good.
Because I did
Everybody's
that,
confused about
I got some
2.6.
weird numbers.
Yeah, mine were like all on one of the asymptotes.
Yeah.
Okay.
Well, yeah, I don't know. I just don't know
Okay,
if it's correct.
now let's just stop right there. You cannot ever have a dot on a vertical asymptote. Now, it is possible to have dots on horizontal asymptotes or end behavior asymptotes, but you cannot ever have a dot on a vertical asymptote. All right, so I'm going to get to that one in just a second. I want to step back over here. Ella, where are we?
Yeah.
How far are we here?
I think I got it. So
Alright.
I got my points were 0, -2. Oh well, yeah, my asymptote was at -1. Sorry.
Yeah, that's perfect. And then you got a y-intercept at -2. That's perfect. Did you have an x-intercept
And
at
then
2?
I got at 2.
Yep, and a horizontal asymptote at y=1.
Yep.
And then you connected these guys like this. And
Yeah,
you
that's
did this
exactly
like
how
you
mine
get here.
looks.
Is that how yours
And
looks?
then I have one up there in the left. Yep.
You got it.
Yeah.
Good job. Now, do you want to work on
Thank
something
you.
else while I'm helping them, or are you done for the day?
I'm done.
All right. I'll see you
Thank
tomorrow.
you.
Bye-bye. Oh, wait, did you want to ask a
Yeah,
test question?
bye.
Ella, do you want to ask a
Uh,
test question?
Yeah, if I can, that'd be great.
Okay, quickly, give me the question. I'll get you started on it.
The one where it's sketch, y = -2, x + 1 squared, x - 2 squared.
I don't know. I don't know that. I couldn't remember everything.
That's right.
But, okay. So, what do you think we should do, Ella?
Factor.
It's already factored, sweetie. These are factors.
Oh, I need to find the PRRs, right?
Nope. Nope. This is way easier than that. This is already factored. You put the dots on the x-axis at -1 and 2 from the parentheses here. Then you count up your x's. How many x's do we have all together?
4.
4. That's even. Even means up,
So you
up.
start up.
Except, see this negative?
Oh, then you start down.
Yep.
If it's negative, you always start down.
No, if it's even and negative, you start down. If it's odd and negative, you start up. You start opposite
Okay.
of where you normally start. So normally even would be up, up, but because of the negative, I'm gonna start down. And then I have to look
And
at my
then-
powers.
You immediately bounce off, right?
Yep, and then connect.
And then you bounce again.
Yep. So
Okay.
if the problem is already factored, if you already have parentheses, then you're just going to jump in and sketch it. You do not have to do anything else.
Okay.
Okay?
All right. Thank you. I'll see you
All right.
tomorrow.
All right. All right, so I'm doing on 2.6, I am doing problem B.
Yes.
So I think as I go, I'm going to try to factor it. So let's see, I can take out a 2x squared, and I'm left with x plus 3. And then I have x, minus 4 plus 3. So I can see I'm definitely going to have a hole. And my hole is going to be where x equals negative 3.
Yes.
So now I'll plug negative 3 back in here. So that would give me on top an 18 over negative 7. Is that what you got?
Yeah. Yeah.
Which I have to plot that, so that's somewhere between negative 2 and negative 3. So negative 3, negative 18/7. Is that all right with everybody?
Mm-hmm.
All right. What else do I have? Let's look at what we have left right here. What else?
X-intercepts and Y-intercepts.
All right, gotta find those. So we got 0 and 0. All right, what happens if I put in 0?
For x,
Yeah, put in 0 for x, yep.
you get 0.
All right. So I got an x-intercept at the origin, y-intercept at the origin. What happens if I let y be 0? Now look.
Is it 0?
Yeah, it's going to be 0 again because you're going to have 0 equals 2x squared if you cross multiply. So that point is a double duty point. Notice it's on the y-axis and the x-axis, so it's an intercept and it's a y-intercept and a 0 at the same time. All right, what else do I need?
Vertical asymptote and horizontal
Where's
asymptote.
my vertical asymptote? Kids, vertical asymptote's at 4. How do I know the vertical asymptote's at 4? Yeah, it's what makes the denominator 0, and 4 makes the denominator 0. Okay? Now, I don't have a horizontal asymptote. How do I know?
Because the top is bigger than the bottom
Yeah.
with the x squared.
If I tried to box that in, like I was talking to Ella a minute ago, if I tried to box that in, I do not have any x squareds on the bottom, so I'd have 2 over 0. So what do I do if the top power is bigger than the bottom power?
You have to use end behavior by
Well,
saying
I'm
like
gonna
take
find
4
it.
out.
I'm gonna find the end behavior asymptote, but how do I do that?
Division.
Yep. So this is 2x squared, no x's, no number, and I'm dividing by 4 out here in the box. Right? Remember, every power has to be represented, right? So that's what it's going to look like. So bring the 2 down. I have an 8 and an 8 and a 32. I don't really care about the 32 though, because if I'm doing an end behavior asymptote, all I really care about is the quotient. So where will be, or what will be my end behavior asymptote?
2x plus 8.
Y equals 2x plus 8. The line y equals 2x plus 8. this is not good. Okay, I'm gonna
Okay.
shrink.
Well, I guess like I ran out of room when I was like on the homework problem, so that's why I was confused.
Yeah, I'm gonna shrink mine down a little bit so that I can see the top part. I'm not even gonna see the top part of the picture, so I'm gonna shrink it down a little bit. What you can do on your homework is change the scale if you want.
Okay.
But now I gotta remember where I had stuff. So I have a vertical asymptote of 4. And I have, well, I didn't do much better, but a little bit better. Yeah, you can see up there. Okay, so here are my 2 asymptotes. We had here, and then we had a hole somewhere, -3.
-3, -18 is good.
Alright. So I've got my vertical asymptote, my slant asymptote, and my intercepts and holes. So now I got to draw the picture. This part is pretty easy, I think. You got 2 points here that have to be connected, right? So I think we got a shape that looks like that in there. Remember, you are not allowed to cross this axis anywhere but here. So don't think you're going to go up and come back down. You can't, because there's no crossing. So it must be just tangent right there, which, oh, by the way, makes sense because when you have x squareds, what do you have? Think about the last chapter we just did.
Yeah, correct.
You got bounces, right? So that kind of bounces there. Now, here's my vertical asymptote. Remember what Ellie was talking about a moment ago? She said, how did you know to draw that over there? And I said, your vertical asymptote splits your paper up into sections. How many vertical asymptotes does this problem have?
It has 1.
1. That means you have split it once, so you got a left side and you got a right side. You've already drawn the left side. Here it is, the asymptote. You've already drawn something on the left. So now you got to draw something on the right. Knowing what you know, where do you think the something on the right is going to be drawn? Right up here. In the opposite corner. It can't be drawn over here, guys, because if it were, it would have to cross. It's clear up here, heading up and out in that little section.
In the opposite one, did you draw a hole?
Yep, it's right here, open dot, right there.
In the opposite one.
No, there's no holes over there. This is the only hole. This is not a symmetric figure, so I don't want you to think these 2 pieces are the same exact shape and everything. They aren't. They're in opposite regions of the graph, though. Just like they've been always. Like originally we had things that looked like this. They're in opposite corners. These are in opposite corners. Here's your intersecting lines. Vertical angles. You got a piece up here and a piece down here. Holes only happen when you cancel. You only canceled out one thing, so you're only going to have 1 hole. All right, so I'm going to ask you a couple limit questions about this. We'll just use this picture since we have it. All right, so see how if you can answer these. We'll do 5 limit questions. Here we go. Yeah. use this picture right here and see if you can get those 5 questions answered. Let me know when you think you've got all 5 and we'll go over them.
Mrs. Ford,
Yes.
I had to go, but I just wanted to say thank you.
Oh, you're welcome. You sure you don't want to wait just a couple more minutes?
No, I had to go pick up my siblings.
Oh, darn, just leave them. Ha ha ha, just kidding.
Bye.
All right, bye. All right, let me know when you got all 5 of them answered, guys.
Okay, I think I have them.
Okay. What about you girls? You got all 5 of them?
I just have the last one.
Okay. All right, let's get some answers up here and then talk about them whether they're right or not. Jacob, what'd you get for the first one?
Alright, I did get positive infinity.
All right. Don't be blabbing on. Positive infinity is what you got. Good. Lily, what'd you get for number 2? We're going to check it. I don't know if it's right or not. We're going to check it. Lily, what'd you get for number 2? Lily. Gotta unmute, sweetheart. We can't hear you.
I'm not sure how to do these ones.
Okay, well, we're almost done, so I hope you've been paying attention. Maybe next time come earlier. All right.
Yeah, I had to hear my.
Ellie, did you get number 2?
I got 0.
All right. Jacob, what'd you get for number 3?
Negative 18 over 7.
And Ellie, what'd you get for 4?
Positive infinity.
And you really, when you write, you don't really have to put the positive. I like to do it though because it just like is a mental signal to me. And what'd you get for number 5, Jacob?
I got negative infinity.
All right, let's see how we did. Let's see if we're right. So the first one said x is approaching infinity. So where is that? Where do I look on my graph if x is approaching infinity?
2x plus 8.
Okay.
Because it's like x is going on forever.
Okay, x is, that's what I want you to say. I want your beating the lies, everybody. 0 right in here. This says go to the right. As and I'm out of room up here, but as I go to the right, I am also going up, right?
Yeah.
Also, correct? And if I am going up and there's no boundary up there, this is exactly the right answer. That picture is shooting up into space. As you go to the right, you're going up. Perfect. All right, now this one says x approaches 0. Now wait a minute. 0 has a point. What did we say about limits as x approaches points?
Sorry. Do we say like it can come from either side?
Yes, but all right, I'm going to say this again. Guys, I don't know what is going on. This is so simple. As limits are y values. If there is a point, the limit is the y value. What is the y value at that point right there?
0.
Yep, you got it right. All right, number 3. Uh-oh, we got a point there too, don't we? Now, I know it's a hole, but it still counts as a point because it's still a connection in the graph. So this is exactly the same thing. I don't care which side I'm coming at it from. If there's a point there, then the limit is exactly what you said, the y value. Perfect. X approaches 4. All right, this is 4. It is not a point, right? It is not a point. So I have to pay attention to which side I'm coming at it from. I am coming at 4 from the left side. So follow your curve. As you go toward 4, is your pencil going up?
It's going down.
It's going down. This should be negative infinity. You're going down. You're going down on the left side. You're going up on the right side. So if this had been a plus, it would be positive infinity because we're going up. All right, and then number 5, what's happening there? Where am I looking here?
Negative infinity.
I'm looking that way, right? I'm moving that way. So as I follow my curve that way, go to the left, I am also going down. Yep. So that is absolutely correct. So I can't remember how many of those we missed, but we got some of them right, that's for sure.
We missed 1.
All right, awesome. Good work. Better than it was. All right, that's
This
it.
is Ford.
Yep.
I have a question on problem 1 for the homework.
All right, quickly, what's your question? I'm not going to do the problem. What's your question?
Well, after I simplified the problem, I got an enumerator 2, x plus 1, and a denominator x plus 3, and I was just having a hard time finding the y-intercepts.
Just put 0 in for the x's.
But if it's 0 equals 2x plus 1, is there going to be 2 intercepts or just 1?
Okay, that's not the y-intercept, that's the x-intercept. The answer would be -1. Lily, don't make it harder than it is. You're solving an equation like this, so simple. Divide by 2, subtract 1. X equals -1. That's the x-intercept, not the y-intercept.
Okay, thank you.
All right, that's it. We'll do this again tomorrow, folks. I hope to see you then.
Thank you.
Bye.
Thank you.
Bye.